Hello and welcome to today's webinar. My name is David Cash. I'm a member of the marketing team here at Mountz, and I'm glad that you've taken the time to join us today as we look at our topic of how to select an ergonomic torque arm. Now, there are a lot of manufacturing challenges that go into the actual process of using a power tool. And one of those things is going to be the reaction forces that tool will give off when it shuts off. And that anytime you're looking at those types of forces, any measurement that would be above maybe 15 to 20 inch pounds or just under 2 newton meters or so, you might want to consider putting that tool into an ergonomic torque arm because the operator itself, they will be using this tool over and over again. And that repetitive shut off and that repetitive reaction force can cause issues with repetitive motion type of injuries and operator fatigue. The other nice thing about using a torque arm is that you are getting 100% transfer of the torque from the tool to your application. And so by using a torque arm, we're looking at the key benefit of being able to protect the operator, or in other words, we're prioritizing the operator by using a torque arm to help eliminate some of those repetitive motion type of injuries that may happen. But we also help to prevent any type of cross thread that may happen. Depending on the type of arm that's being used, we can use the tool, keeping it in a stable position to help mitigate any type of cross thread. Also, we're going to be looking at being able to eliminate any type of side load that may happen as well. And this is really, really important, especially if we're looking at really low torque values. Now, there may not be as much of a process or much the way of operator fatigue using a power tool at such a low torque value. The problem is the side load that could introduce inaccuracies in that process by not keeping that tool perfectly vertical, if that is the orientation that we want to use that in. And then also we're protecting the tool from any type of drop damage that may happen because the tool obviously is secure in the torque arm. And so those are some of the challenges, and the benefits that work alongside of that is kind of what we just talked about. We're reducing the stress injuries that can be associated with assembly for the operator. That can include any type of wrist injuries or carpal tunnel, any type of shock that way. Obviously the benefit of the torque arm is it's absorbing all of that reaction from the tool itself, and not allowing any of that to be transferred to the operator. And as we mentioned, tool alignment. But there's also one thing to keep in mind as well when we're looking at torque arms, and that is something that sometimes is often overlooked, and it is the dominant hand of the operator. Because of the rotation of most fastening operations, the tool should be used in the operator's right hand if we're not using a torque arm. And that's because when the tool shuts off, that force or reaction is kind of going into the body through the arm of the operator. If you have an operator that is using their left hand during this operation, what tends to happen is the tool will shut off and the operators will kind of be absorbing all of that shock through their wrist. And so if we're using right-handed, it's more of this motion. But anyway, if you're using a torque arm, in any case, that eliminates the operator's dominant hand being used incorrectly for the application itself. So we'll going to look at the different arms that we have here. Again, these arms can be used with either an electric power tool or a pneumatic power tool. So that could be an electric clutch tool, could be a DC control tool. It also could be pneumatic tools with air shut off. One tool that you may not necessarily need to put into a torque arm is going to be a pulse tool. And that is because it is designed to be able to be used at higher torque values without giving any type of shock or reaction to the operator. The trade-off in that is going to be the accuracy that the tool generates. And so that tool has a much wider variance to it than would be with a standard clutch tool, pneumatic or electric in that case. So when you're looking at selecting a torque arm, there are a few things that we need to keep in mind. First, obviously, we want to select the correct arm for the correct torque output that we are trying to achieve. So we want to make sure that we are below the threshold of the arm. Obviously, that would be one component of looking at our torque arm. Next is going to be the style of tool that we're using. Is it going to be a right angle tool? Is it going to be a pistol grip tool? Is it an inline tool? And we might need to make appropriate arm recommendations based off of that. The mounting location of the arm, is it going to be mounted on the work surface? Will it be mounted on a rail system? Will it be mounted on a wall? All of these different things can play a part in which arm we may need. And again, this is all going to be primarily application specific. So our examples that we'll be showing today are going to be the use of the tool in a standard type of orientation, but there are a lot of different scenarios that require a lot of different types of solutions. And so we can look at that as well. And then finally, we want to look at the total weight load that the arm is going to be able to support with the tool that we are selecting. And the weight component does not only just include the tool, but there are things that we need to consider as well, which is going to be the weight of the cable once that gets put onto the tool. Also, we're going to have to look at the socket or bit that is going to be associated with that tool. So we need to look at the entire weight that's going to be given to the tool to make sure that that is going to be able to hold or be within the specifications of the particular arm. And so sometimes that can be tricky, where we look at the capacity of a torque arm, look at the tool, and then we can go ahead and spec that one. But we need to make sure that we're also adding the weight of the cable and any type of bit or maybe a vacuum assembly, things like that, that will increase the weight to make sure that we're within the capacities of the torque arm. Now, there are a lot of different styles of torque arms. We're going to highlight three styles today. That's going to be the linear torque arm, the articulated torque arm, and the telescoping torque arm. So let's go ahead and take a look at each of these independently, and we'll look at some of the characteristics that make up these different arms. Now, the first one that we'll look at is going to be the the linear arm. And this arm does give us three different axes of movement. We have up and down, we have right and left, and then we also have the ability to go in and out here on this type of tool. Now, this does keep the tool perfectly perpendicular to the work surface, and it can be adjusted through the length of rails that may be given or the placement of the arm to the bearing sleeve here. But again, this is going to allow us to be able to keep the tool in a perfectly vertical position to help prevent against the cross thread or again, prevent any type of side load that may happen with the torque arm. Does have balancers on it here that can be adjusted to accommodate the weight of the tool as well. And there is a magnet here to keep the tool locked when the arm isn't being used. So this is a real good option to allow the arm to be placed back on the work surface. Pull the arm out when it's need to be used. Go ahead and use it, and then put the arm back where it is stored. The next arm is going to be the articulated arm. Now, both of these arms have a unique feature to them that do allow us to be able to change the orientation of the tool holding. So there is a fastener in here that attaches to the tool holder, and I have it loosened right now, but we can go ahead and we can change that orientation to accommodate an inline tool. If we want to accommodate a right angle tool, we could do that as well. And this would fit in like this, and we could then use the right angle tool in this orientation here to accommodate that style of tool. Now, the basic difference between the articulated arm and the linear arm is going to be the ability to adjust the arm here. We can, right now it's at a 45-degree position from the cross arm. We can move this to 22, or we can come all the way up to 0. So 22.5 degrees or 0 degrees. We can also change the orientation of where this is to affect the reach that we're looking. But the articulated arm does give you a little bit more area to work with for your particular application. Or you may have height restrictions because of some componentry that may be on the application. And so if we're using an inline tool, having the ability to adjust the arm here gives us the ability to get to that location, and where the linear arm may not allow for that type of access. So again, these arms are very similar, and the big difference is going to be the ability to adjust this and the work area for that particular arm. Now, these styles of arms can go up fairly high in the range that we're looking at. So up to 200 Newton meters that we would be looking at, or sticking out in 8 meters. So all of these are going to be able to fit in most applications that we are going to be looking at. The next arm is going to be the telescoping arm. And this one is an arm that those operators that may be resistant to change would most likely enjoy, because the tool is still on a balancer. It, though, allows for free access movement of the driver, and then the operator can go ahead and use it. But they do have all of the benefits of absorbing the torque that it is being generated by the tool. So as this is used, the operator can move it in any direction they want, in and out, up and down, or if there are some angle requirements for a particular application, the telescoping arm would be a good choice. So again, up to 200 Newton meters on this style of arm. And in some cases, we can go a little bit higher with longer reaches. Again, it's all going to be application specific, but there are a number of different solutions for a lot of different types of arms. Now, one arm that we're going to highlight as well that is not here on this demonstration is going to be our Posy Touch, or our location control torque arm. Now, the real benefit of this arm is that it works in conjunction with our Posy Touch system. And this arm basically allows the operator to move through the assembly process and error-proof the entire assembly. So the arm itself has encoders on it that monitor where the tool is in space. And if the tool is not in the right location, it does not provide power to the tool. It works through the actual sequence of the application, and it is controlled with, again, the use of our Posy Touch system. So I'm going to play a little clip here of a demonstration that we did a while back. And it runs through the use of this system with our Posy Touch in the process control. So ahead and look at a solution that is one that we use quite a bit, and that's going to be our Posy Touch system, which works in conjunction with our smart ECT, our EC tools, as well as our ECTD tool. It consists of our Posy Touch display and also our positioning control arm. And so the Posy Touch display helps to move the operator through a particular assembly, and it completely error-proofs the process, allows for different types of jobs that we can do within the use of the Posy Touch. It also gives us the ability to control a lot of the devices that we just looked at. So let's go ahead and we'll take a look at the demonstration for the Posy Touch. And so right here I have our demo assembly that we typically use to demonstrate this. And it as the Posy Touch system here, we have connected to it a light tree. We also have proximity sensors here. We have proximity sensor here. We have our lock assembly. We have a few buttons, and we have our emergency stop button as well. We also have our position control arm hooked up to this as well. And the way that this works is that we have encoders that will monitor where the tool is in space. And this helps to actually guide the operator to a specific part, a specific assembly that they would be doing. And it only provides power to the tool when the operator is in the right place. And not only does it provide power, but it will also provide the correct preset that needs to be used. And it'll help walk the operator through the assembly. So we also have our Posy Touch display here. I have it next to our ECTD controller. And at the moment, you can see that the screen is telling us to go ahead and press the button to start the program. And right now, the controller is locked. And so if I try to go ahead and use the tool, you can see we have no power to that. And so the way that this system works is built on steps. And so a step must be completed until the process will index to the next step. So our first step here is to go ahead and press the start button. And so I will do that here. And now we need to go ahead and load our workpiece into our jig. Once we've done that, the assembly has been secured. And now we can move on to the next step. We need to go ahead and pick from bin A. So once I've done that, we now can go ahead and begin our fastening process. Now, just for time's sake, I have the fasteners already in the unit, but again, unless I'm in the right spot, I don't have power to the tool. And you can see our location is being guided for us. We currently have a red mark. Once I get over the correct location, that will turn green. And now we have power to the tool. You can see it says OK. And we'll go ahead and run this first fastener. Now, this is going to be a two-step fastening process. And so once we run through that, we will then go ahead and tighten these same fasteners down to a final torque value. And so right now I need to select bin A and go to our location. Although we have a good fastening, a good rundown there, we can go ahead and select again from bin A. And again, I have no power unless I'm in the right spot, so I can navigate to the correct location. The light has now turned green. And not only that, but we actually changed to a different preset. So now we're using preset 2 for the for that fastener. When we move to our next fastener, we should go ahead and get a preset change as well. So now we're using preset number 3, and we can run this down, and this will then go ahead and allow us again to have power to the tool only when we're in the right spot. And so we have all of these automation devices working in concert with each other to make sure that the assembly is done correctly. And now we're going to go ahead and go to our final pass. And again, for this, we are using preset number 4. And now that job has been complete. The lock has been released. We can go ahead and move our part out, and we can press the start button to begin the process again. And so with this assembly, there are a lot of different things that we could do as well. We can incorporate the use of a barcode scanner to bring up a specific program. And so if I want to do that, I can simply scan a barcode. And now say this was a rework type of scenario, our instructions are to go ahead and load the workpiece. So we load the workpiece, and now we can loosen the screws in any order we want. And so this is a little different than what we did before, because we now have the option to do the fasteners in any order that we would like. Now the system does know where each fastener is, and once a fastener has been completed, it can no longer be used again. So it is recognizing the location, and if it has been used, it will not provide power to the tool if it is in that location. You can see our preset is now preset number 5, which is a different preset. This is actually just going to pull the fastener up to a certain location, or excuse me, a certain amount of degrees. Okay. Now, if I try to come back to this particular fastener, again, we have no power until we're in the only fastener that is available left for us to work with. We then can remove our workpiece, and the job is complete. All right, so that gives you a little bit of how the Posy Touch system works in conjunction with the position control torque arm. That allows the operator to be guided through the assembly process, giving the operator the ability to make sure that every fastener gets torqued, it gets torqued correctly, because it can't move on until a specific step has been completed and it's been completed correctly. So with that, that's going to conclude today's presentation on torque arms. Now, we do understand that there are a lot of, again, special types of applications that may require different types of setups for different arms, and that is something that we certainly can look at and help you with going forward. So with that, that's going to lead us to any questions that we might have today. So let's move in to our questions and answers. And so, Chris, do we have any questions?
Morning, Dave. Yeah, I've had a couple of questions. First one was, the tool balancer, is that included with the arms, or is that purchased separate?
Yeah, the tool balancers are included with the arms. And again, that goes to making sure that we're using the correct weight load within a specific specification for a specific style of torque arm, just to make sure that we're going to be within those specifications. Again, we want to make sure we've got the tool weight, the cable weight in any socket or bit, or mouthpiece that might be on the tool as well. So we take all of that into consideration for the weight of the tool, compare it to the correct arm, because the balancers do come with the torque arms.
All right, thanks. The other question we had was, on the balancer, do we have to adjust the tension or when you set up a tool on it?
Yeah, so the balancers themselves can be adjusted to make sure that there is not too much force that is being used on the tool. We don't want the operator to have to struggle to push down on the tool. So the balancers themselves can be adjusted to the correct amount of tension so that the operation and the arm move well with the operator during the assembly process. All right. I want to say thank you very much for joining us today. And I hope you join us again next month for our next webinar. Have a great day, and we'll see you soon.